So, a quick little video on the EVT Performance designed and built launch box. This is a new product I'm going to be releasing here in the next little while. I do have a couple of test models going out to some local guys here to see how they're going to do. So, what is the launch box? The launch box is a custom two-step rev limiter system based off of an Arduino for now until version 2 will come out, which will be a self-contained unit. Not this Arduino, it's got one on the inside there. So what does it do? When you either activate it with the momentary switch, or if it reads RPM above where you set it, it will activate the two-step, which cuts spark. Now, why do you want this? There's a couple of reasons why. Number one, if you want to be a showboater, it'll give you that nice pop out of your exhaust. But if you have a catalytic converter, you probably won't have one for very long if you install this. Now, the other reason for this is when you start building a car, you've got a turbo that's running high boost, and it's big in the drift world. The factory ECUs, what they do is they cut fuel to the cylinders to limit the RPM. Now that is bad because you'll start leaning out a cylinder. The cylinder leans out, or multiple cylinders lean out, and it's just a ticking time bomb. So a ignition cut limiter does the opposite. It pulls ignition rather than fuel, which is good because it also helps with spooling up your turbo from a launch. Now, how does this work? Quick rundown. 4 knobs. We've got duration, which will set how long it cuts it for, or how long each pulse is held on. Now, each pulse grounds out the coils. So a shorter pulse might only ground 1 or 2 cylinders, which is good for like a 4-cylinder engine. A longer pulse might cut 2 to 3 cylinders or more, depending on RPMs and whatnot. Now your speed, which is the setting in between pulses, and that'll change how it acts and behaves. And you're gonna have to tune this for your vehicle. I recommend starting with a shorter pulse and a shorter duration and a longer pulse, and then dialing it back from there. So now our other knob here is the maximum RPM setting. So when your vehicle exceeds the RPM that you set on this knob, this box will read it and activate the two-step, which will limit you from over-revving. And as well as this, it's got a built-in shift light knob. So that's what the 4th knob here is for, is setting your shift light based on RPM. So I've got an Arduino Uno here, which is set up to simply just simulate RPM. So, and as well as I've got the proto board on here, which is just a quick, easy way for me to test these units. It's an all-in-one, just plugs right into the harness. It comes with them. So momentary activation, you'll see here, I'll press the button and you'll see that red LED on the right flash and the purple LED here flash. The purple LED is just showing us that it's grounding out the coils. Ready? Yeah, that was pretty fast. We can dial that back down a little bit. Now you can see it's going a lot slower. There is 2 mode settings, so there's a switch on the back here, which I've installed. I keep mine on pulse mode, but if you switch this flip, or switch this, if you flip the switch, sorry guys, if you flip the switch up, it puts it into burst mode. Now let me show you. Burst mode is a series of 3 fast pulses with a break in between. Right, now I'll turn that down so you can see it better. Now the LED is flashing slower than what it's actually doing. The relay inside is going to activate 3 times per 1 flash of the LED. So you can see it here. That one's flashing slow, but that one's flashing really fast. Now, with the pulse mode, which is awesome and fun to play with, you can, like I said, you can dial it down. Now, like I said, we've got the Uno here, which is going to be running an RPM pulse. It starts at 2,000, and it's going to ramp it up to 8,000, and it's going to bring it back down. It's just going to keep going back and forth. So now I've got my RPM setting, which this RPM setting will go up to, it'll limit up to 12,000 RPM. So you can tone it back. And because I've got this more designed for my car, which I don't want anything really above 7,200 RPM, which would be about there. Now you can see when it comes up in the RPM, it's going to activate it, and then as soon as it reads that the RPM is below that point, it's going to shut it off. Now we can introduce our shift light. So we can dial this down, and we want it a little lower than our RPM. So if you watch, this red LED, it's going to turn on for a second, solid, and then it'll flash if it goes over 250 RPM above that setting, and then it'll flash faster if the two-step is engaged. So I'm going to tweak that. And you can set it wherever. You want this thing to limit at 2,000 RPM, it'll do it. But we can bring it back up. And you can shut it off just by turning the knob all the way to the right if you don't want to run it. The shift light, like I said, you can adjust wherever you need to. And then momentary switch, which you would have to mount in your vehicle. You'll see it's trying to run the shift light and the two-step at the same time because it's still sweeping. So I'm just going to tweak that up. There, and go back to pulse. I myself like the burst mode just because it kind of gives you that stutter. It doesn't cut it all the cylinders at the same time. It's a really fast 3-shot burst. Pretty cool. If you guys are interested in this, please let me know. I am looking for a couple of people to test these on their vehicles. Now I will mention right away that these aren't free. I'm not giving these away. If you want to test one, the cost is $80 Canadian. And that just simply covers the materials for it, the 3D printed parts, the main controller, the code I put in there, all of the hardware, the software, everything. It covers that, which just helps me out, and you got a good deal on them. Once these are released, they're going to be for sale for roughly $120 to $150 Canadian. I figured it'd be fair, and then any improvements from there will be updated as they are produced. Pretty straightforward. If you guys have any questions, let me know. Once I'm happy with these and it's proven that these are going to work, I'm actually going to make these an open source file. So you'll be able to go into GitHub, get the 3D models for the case, the parts list, the code for the Arduino, the schematics to build it yourself. Everything you need will be there. But that's going to be a couple months off yet. Alright guys, thanks for watching. Have a great day.